Today we'll prove the formula for integrating an exponential function with base a. Specifically, we'll show that the integral of a to the x equals a to the x divided by the natural log of a plus c. Let's prove this using two different methods. First, let's use the standard method. The key is to recognize that the derivative of a to the x equals a to the x times the natural log of a. Using this fact, we can rearrange our integral. First, multiply and divide by log a. This gives us 1 over log a times the integral of a to the x times log a dx. Now we recognize that a to the x times log is exactly the derivative of a to the x. Therefore, when we integrate it, we get back a to the x. Therefore, our final answer is a to the x over log a plus c, which proves our original formula using the standard method. Now let's prove it using the series method. First, we can write a to the x as e raised to x log a. Using the power series expansion for e to the x, we can write this as an infinite sum. The sum from n equals 0 to infinity of x log to the n over n factorial. Now we integrate term by term. For each term, we integrate x to the n, which gives us x to the n plus 1 over n plus 1. This series can be recognized as the expansion of a to the x over log a. Therefore, we again arrive at our original formula. The integral of a to the x equals a to the x over log a plus c. We've now proven this formula using both the standard method and the series method, giving us confidence in our result.